Hello everyone and welcome to the channel. So today I'm going to show you the different types of Arduino, ESP8266 and ESP32. So basically this is the first episode of our Arduino tutorials, in which in this episode I'm going to cover some of the basic hardware of these boards and their specifications. So first of all, we have Arduino Nano, which is based on Atmega 328P IC, same as Arduino Uno. Here you can see. Atmega 328P. So there are two different variants of this board. One is based on Atmega 328P, like this one, and the other one is based on Atmega 168P. The main difference between these two is of memory. This one has 328 KB and the other one has half of it. And if you look down, this IC basically communicates with your laptop and Arduino software, which is installed on your laptop. And this right here is your voltage regulator, AMS1117. So if we look at the board, we have 7 analog pins, 8 basically, A0, A1 up to A7. These pins are for analog input, like sensors and you can say analog sensors and your voltage regulators, name any sensor. So these pins are for analog input. These pins cannot provide any kind of output. These are only used for input. And if we look at the other side, we can see the pins are TX, RX. These are for serial communications, and reset pin, ground, D2 to D12 and D13 right here. So which gives us almost 11 pins for digital communication. Okay, so on this side the pins are named as V in, ground, reset, 5 volt. So on V in pin you can provide up to 12 volts, and these 5 volts are coming from AMS1117. And there's also a pin of 3.3 volt and reference. This pin basically gives reference to the analog input. You can provide reference voltage right here and calculate the analog input from these pins. This board basically connects to your laptop using this cable. And there's another board, Arduino Pro Mini. That board is quite smaller than this one, and it doesn't have this IC, which is for serial communication. Now a lot of people have when they first plug in their Arduino in their laptop, they cannot upload the code because they don't have the hardware drivers for this IC. So if you are stuck on that part, just download this CH340C drivers. They're easily available on Google. If you look it up and just download and install it, and you will be good to go. So the second number is Arduino Uno. This one I have is a dip package. You can replace this IC if it's not working. There is another variant of this board which comes as a SMD IC. There's a SMD IC on the board, not this one. So if we look at this board, we can see that there are reference, and this is power rail. This is power rail and this is analog input. as you can see it's written here, analog input and digital outputs. So you can also provide this one 12 volt on VIN pin and take 5 volt and 3.3 volt from these two pins. These are for ground, and A0 to A5 is analog in, and this size is for digital outputs. Now if you look at the pins, pin number 3, 5, 6, 9, 10 and 11, there is a symbol right in front of them, this one. This indicates that these pins can give PWM as output on these pins 11, 10, 9, 6, 5 and 3. These pins can provide PWM signal which can be used to control your servo motors, or your DC motor speed controller can be powered from there. These pins basically will provide PWM signal, and you can operate any kind of servo from there, or you can bright or use your LED for low and high brightness. We'll cover that in next video. So these pins are for serial communication, and you can also power this board from 9 volt adapter, 9 volt or 12 volt. This right here is AMS1117 voltage regulator, and this is your power circuit, basically filter circuit, and this right here is your communication IC. So this one is made in Italy, and there are a couple of these boards made in China. So if you ever buy some board, make sure to authenticate its original. Now this is ESP8266, also known as NodeMCU. So on this board we can see that this is the main IC. This is the main IC, and these connections are taken from these parts. CP2101 IC for serial communication. This is Android jack for connecting your PC, and this is AMS1117 3.3 volt regulator. As you can see, it's written. AMS1117 3.3. So these boards, Arduino, Uno and Nano, these boards can provide 5 volt output, and this board can only provide up to 3.3 volt at its output. That means digital output and analog output as well. Analog means your PWM signal. It can only provide up to 3.3 volts, whereas these boards can provide 5 volts. So a lot of people try to communicate these boards, so they get stuck because the voltage level of these boards is not same. So you have to make a voltage divider and then connect these boards together for better communication. We'll cover that in next videos. We'll show you how to communicate these boards. So this board is basically, this board has only one analog input, and the rest of the pins are digital outputs. D1 and D2 are for also used for I2C communication, and we can also provide voltage from VIN pin. We can also provide 10 to 12 volts on VIN, and the board will power up because the VIN pin is connected at this regulator. But I'll suggest you that you can only use up to 9 volts just to be on the safe side. So these two buttons are for reset and restart. These pins are marked. Now if you look at the downside, on the top it says D0. but on the bottom it says IO16. So when you're coding for your NodeMCU, you have to write 16 IO number in your code, not D2. This way you will tell the board that I want this specific pin to turn high or low. So now the next one is ESP32 room. So the ESP8266, it has onboard Wi-Fi IC. It can communicate with Wi-Fi pretty easily, and it's very handy when you're making some IoT project or any appliance that you want to control with Wi-Fi. So this board is very cheap and very useful. Now if you look at this ESP32, you can see that this one is also Wi-Fi enabled, but there is also Bluetooth inside this board. So you can also use Bluetooth and Wi-Fi at the same time. So this board also uses CP2101 for serial communication, 2102 sorry. So for serial communication, and this is AMS 1117 3.3 volt. This board also can provide 3.3 volt on output, not more than that, and also it can only take 3.3 volt as these digital inputs. If you provide more than 3.3 volt, there's a chance you might damage your voltage regulator or your main IC. So these are the pins for analog and digital inputs. And now on this board ESP32, the analog resolution is 4 kb, which means 4096, and on these boards it is 1 kb, 1024. But this board is not recommended for analog operations because this board does not communicate well with analog devices such as your analog sensors or current sensors. Basically this board gives you inaccurate values if you try to obtain your voltage or any analog signal. So if you look at this side, there is 3.3 volt, ground, D15, D2, RX2 and TX2. Now on these boards only one transmit and receive pins are available, but on ESP32, because this one is dual core, there are two transmit and receive pins which can be used for serial communication. For example, if you're trying to connect these two boards, you want this board to send its data onto this board, and this board is connected with your laptop, then you will have to connect its transmit pin with RX2, its receive pin with TX2. That way you will not get any error, and you will also see your both boards data on your laptop. Because by default its transmitter receive pins are TX0 and RX0, which are responsible for serial communication with your laptop. These two pins are for backup. These can be defined in code. You can also define software serial pins. Any of these pins can be turned into serial communication pins between boards, not between your laptop and this hardware. For boards communication, you can use software serial, but to upload the code on your board, you have to use these two pins because this IC is connected with these two pins, RX0 and TX0. So this board is very powerful for your projects and Wi-Fi communication. Also, you can use it for Bluetooth communication. We'll cover it in next videos. We will cover all of these boards in next videos. I will make some more tutorials to explain these a bit in depth. So now comes the ESP32 cam. Now this small board is very powerful, and because it's also based on ESP32S. So this one has Wi-Fi and Bluetooth inside this IC, as you can see, and this one is for external antenna. If you want more range, more Wi-Fi range, or you have to or you want to connect this board via Wi-Fi at some larger distance, you can use external antenna, but it also has internal antenna. If you want to use external antenna, there are these jumpers. You have to disconnect this resistor R3 from this jumper and solder these two jumpers right next to the antenna port. That way you will enable the external antenna. Otherwise, by default, its internal antenna will be used for signal transmission and reception. So if you look at the downside, we have ESP IC and AMS 11733. This is 3.3 volt. So basically this board has a few number of inputs and output pins, because this is a small board as compared to these boards. This was basically designed for imaging and also saving the data on your SD card. There's a SD card port right on this board, so you don't have to add any external SD card port on the board, or any external uh, any external modules that will consume your money and space as well. So as we can see, there's an LED on this board which is connected to pin IO4. So we have 3.3 volt, IO16, IO0, ground, VCC, UDR and UDT. These two pins, UDR and UDT, these are responsible for serial communication of this board. On the other side we have 5 volt, ground, IO12, IO13, 15, 4, 14, 2 and 4. So to upload code on this specific board, you will need its programming hat. They provide it. There are some websites on which you will find it. However, I made my own custom hat. Let me just grab it. So this I made for the ESP32 cam programming. To upload your code, you have to connect these two pins. So these pins are ground and IO0. When you short these pins, the board goes onto boot menu, bootloader mode. So I made this board and I made its video for you. If you want to make this board yourself at home, you can easily follow my video and make this one. There are total 4 connections: transmit, receive, power and ground. So power goes to 5 volt, ground goes to ground, and the transmit, if you see here, this orange one is receive, it is going to transmit, and white one is transmit, it is going into receive pin. So when you connect this board with this jumper on with this jumper in, you will get to upload the code. on this board. And now if you want to serially communicate this board or watch on serial port or serial monitor the data that is coming inside the board, just remove this jumper and this will connect to your laptop pretty easily. Now I've made this using this board. I've made a spy car. You can also watch that on my channel. I made a video of it. So I hope this tutorial will help you all people. My English is not so good, so I'm trying to do my best. I hope this video helps you, and stay tuned for next tutorial. Thank you.